Hi guys, this is Meghana Bia, studying in Shri Venkateshwara College of Engineering, currently pursuing in 6th sem. Today's my topic is about Cohen Sutherland line clipping algorithm. So we'll see what the today's agenda of today's topic. So we'll be seeing introduction to line clipping and what is Cohen Sutherland line clipping, its algorithm and one problem, and then we'll finish off with the benefits. So, what is line clipping? Line clipping is a clipping concept in which lines that lies outside the clipping window is removed from the clip region. So, as a result, only the lines which is inside the view planes are visible. And Cohen-Sutherland algorithm is one of the popular line clipping algorithm used for this purpose. You can see an example. So, the input will be given and the output is displayed. Next is Cohen-Sutherland line clipping. So Cohen-Sutherland uses the region code to clip the portion of the line which is not present in the visible region. So it uses the region code, that is 4-bit region code, which represents the top, bottom, right, and left. And also the region is divided into 9 columns based on X max and Y max, and then X minimum, Y minimum. And also you can see the central part, so that the part is a viewing part, and that is uh, all the lines which lie in that region are completely visible, so that is the viewing part. And the region code is always assigned to the endpoints of the given line to check whether that line is visible or not. So this is the viewing region, and here the code will be 0. So also then we'll see that how a line can be drawn. So it can be drawn in 3 cases. That is, case one is inside the window. So when it is completely inside the window, it is visible and no clipping is required. Then case two, completely outside the window, that is invisible. So no clipping is required because entire line isn't inside the window. Then third one is partially inside or outside the window. So this is partially inside and outside the window. Then we have to find the intersection points and clipping would takes place. So this is the intersection points and these extra parts are removed. So we'll see the algorithm for this. In step one, you have to assign the region codes to both the endpoints. That is, if we consider this as a line, then you have to consider the region code for these 2 points. So after considering, you have to perform the OR operation on both of the endpoints. So when you perform the OR operation and if the result is 0, 0, 0, 0, then the line is completely visible. That is, when OR operation is performed and if you get 0, the line is inside the window. So this line will be visible. Else, if that is not 0, 0, then you have to perform the AND operation on both of the endpoints. So after performing the AND operation and that is not equal to 0, 0, then line is invisible and not inside the window, and also it cannot be considered for clipping. That is, this invisible line is not inside the window. Then else if AND operation also we get 0, 0, 0, 0, then line is partially inside the window and considered for clipping. That is the case 3. So when you perform AND operation and if you get 0, 0, 0, then the line is partially inside the window. So the step 5 is after confirming that the line is partially inside the window, then we find the intersection with the boundary of the window. That is by using the formula, slope formula, that is m is equal to y2 minus y1, x2 minus x1. Then again we have 4 cases after considering the slope. So if the line passes through top or the line intersects with the top of the boundary of the window, then x will become equal to x plus y maximum minus y divided by slope, and y will be equal to y max. And if the line passes through the bottom or the line intersects with the bottom boundary of the window, then x will be equal to x plus y w minimum minus y divided by slope, and y will be equal to y minimum. And the next case is if the line passes through left region or left intersect with the or the line intersects with the left boundary of the window, then y will be equal to y plus x of w minimum minus x into slope. So and x will be equal to x w minimum. And suppose if the line passes through the right region of the line intersects with the right boundary of the window, then y will be equal to y plus x w max minus x into slope, and where x will be equal to x max. So you have to perform using these formulas. And uh, after we find the points, we'll move to the next step, that is now override the endpoints with the new one and update it. So once we find the endpoints, we have to update it. And the last step will be repeat the step 5 till your line doesn't get completely clipped. So this is the algorithm. Next we'll move on to the small problem. So we have a line AB, and the point is 30 60 and 60 25. So and the window positions are xw minimum and yw minimum is 10 10, and xw maximum and y maximum will be 50 50. So you can see the diagram. So this is partially inside the window, so we have to find the intersection points, that is P1 and P2. So first, we'll find the line slope. So applying the formula, we get the slope is equal to minus 7 by 6. So we can see that line is intersecting on the top region and the right region. So we'll find the points xt, that is equal to x1 plus y max 1 minus y slash m. So, finding the x point, we'll get 17.56. So, the intersection point will be 17.55, comma 50. And next, the line is intersecting at the right, that is a P2 point. So, we'll find the y point, y plus w max minus x into m. So our x point will be equal to 12.167. That is, P will be equal to 50, comma 12.167. So these two are the intersection points. So this is Cohen Sutherland line clipping algorithms. Now we'll see the benefits. So it is very simple and easy to learn and also to apply. And it calculates the endpoints very quickly and rejects and accepts the lines very fast. And also clip pictures are much larger than the screen size, and it can be easily extended for 3D line clipping. So this is the end of the video, guys. I hope you guys liked it. Thank you for watching it.